Bismillahirrahmanirrahim. Strabismus, or ocular motility in health and disease. Anatomy and physiology of the extraocular muscles. Each eye is moved by 6 extraocular muscles, 4 rectus muscles or straight muscles, and 2 oblique muscles. They are called rectus because they are straight. They have an almost straight course. The 4 rectus muscles are the superior rectus, the inferior rectus, the medial rectus, the lateral rectus, and the 2 oblique muscles are the superior oblique and the inferior oblique. Origin. The origin of the 4 rectus muscles is from the tendinous circle of Zen, which is located at the orbital apex. The origin of the superior oblique muscle is just above the tendinous circle of Zen. So it originates from the orbital apex above the annulus or the tendinous circle of Zen. This is the anatomical origin. But the physiological origin, which determines its action, is the trochlea. The trochlea lies in the upper anterior medial part of the orbit. So the superior oblique originates at the orbital apex and then courses anteriorly to reach the trochlea, where it turns and moves backwards to be inserted in the back of the globe. So the physiological origin is anterior at the trochlea. The inferior oblique originates anteriorly at the lacrimal fossa, or the fossa for the lacrimal sac, which is located at the anterior, inferior, medial part of the orbit. Course. We have to know certain definitions at first. Optic axis is the line passing through the center of the cornea, center of the lens, nodal point to reach the posterior pole, which is midway between the optic nerve and the fovea. Visual axis is the line passing through the object of fixation, nodal point to reach the fovea. Muscle axis is the line passing along the length of the muscle. In the primary position, the vertical recti, the superior rectus and the inferior rectus, they course from their origin nasally to reach their insertion temporally, making an axis of 23 degrees between the muscle axis and the optic axis. So the vertical recti are located 23 degrees temporal to the optic axis. The obliques are located 51 degrees nasal to the optic axis. So the angle between the obliques and the optic axis is big. That's why they're called oblique muscles. Insertion. All extraocular muscles are inserted in the sclera. The 4 rectus muscles are inserted in the sclera in front of the equator, in the spiral of Thilot. The medial rectus is closest to the limbus. It's inserted at 5.5 millimeters from the limbus. The inferior rectus at 6.5, lateral at 7, and superior at 7.5 millimeters from the limbus. So they make a spiral. The insertion of the oblique muscles is behind the equator. They are inserted in the posterior part of the globe. On the temporal half, the superior oblique is inserted in the superior quadrant and the inferior oblique in the inferior quadrant. Nerve supply. The oculomotor nerve, or the third cranial nerve, supplies all extraocular muscles except the superior oblique and the lateral rectus. So it supplies the superior rectus, inferior rectus, medial rectus, and inferior oblique. It also supplies another extraocular muscle that does not move the eye but moves the lid, which is the levator palpebris superioris, which is responsible for opening the eyelid. And it supplies 2 intraocular muscles, which are the ciliary muscle, responsible for accommodation, and the sphincter pupillae muscle, responsible for constriction of the pupil or meiosis. The 4th cranial nerve, or the trochlear nerve, supplies the superior oblique muscle, and the 6th cranial nerve, or the abducent nerve, supplies the lateral rectus muscle. action. As the horizontal rectus muscles, the medial rectus and the lateral rectus, they course straight from back to front to reach their insertion with no obliquity or any angle between them and the visual axis. They only have one action each. So the medial rectus, which is located nasally, when it contracts, it will adduct the globe. The lateral rectus will abduct the globe. However, the vertical recti and the obliques each have 3 actions, and this is due to the angle between the muscle axis and the optic axis. So the superior rectus, which is inserted in the upper part of the globe in front of the equator, produces elevation of the globe. The inferior rectus, as it's inserted in the lower part of the globe in front of the equator, produces depression of the globe. On the other hand, the obliques are unlike their names. The inferior oblique produces elevation and the superior oblique produces depression of the globe. Why? Because they are inserted behind the equator. So the inferior oblique and the superior oblique, they arise anteriorly and are inserted behind the equator. So when they contract, when the inferior oblique, for example, contracts, it will depress the back of the eye. So it will elevate the front of the eye, just like the seesaw. The same for the superior oblique. When it contracts, it will elevate the back of the eye, so will depress the front of the eye, so it produces depression, just like the seesaw as seen in this picture. So the elevators of the globe are the superior rectus and the inferior oblique, and the depressors of the globe are the inferior rectus and the superior oblique. So this was the first action. The second action is adduction by the vertical recti and abduction by the obliques. So the vertical recti are adductors because they originate nasally at the back of the at the orbital apex, and they course anteriorly to be anteriorly in a direction that's temporal to the optic axis. So when they contract, the more temporal insertion will move towards the more nasal origin, so they will adduct the eye. The obliques arise anteriorly from the nasal part, and they are inserted temporally at the back of the eye. So when they contract, they will move the more temporal back of the eye nasally. That is, they will adduct the back of the eye. If they adduct the back of the eye, they will abduct the front of the eye, just the same as the inverted elevation and depression. So the vertical recti are adductors and the obliques are abductors. And to remember that, we can remember that obliques have a B, and so abduction has a B also. So obliques are abductors and the vertical recti, the superior rectus and the inferior rectus are adductors. And the third action is torsion, which is rotation of the globe along the anteroposterior axis. If the 12 o'clock meridian rotates inwards or nasally, it's called intorsion. If it rotates outwards or temporally, it's called extorsion. The superiors, the superior rectus and the superior oblique, are intortors and the inferiors are extortors. And again, it's explained by the movement of the insertion towards the origin. So the superiors are intortors and the inferiors are extortors. So to summarize, the vertical recti and the obliques each have 3 actions: superior rectus elevation, inferior rectus depression, inferior oblique elevation, superior oblique depression. The obliques are abductors, the vertical recti are adductors, the superiors are intortors, and the inferiors are extortors. Field of action of the extraocular muscles. The field of action, we mean if we move the eye from a certain position, only one muscle will function. For example, if we move from the primary position, the superior rectus and the inferior oblique both will elevate the eye. If the patient cannot elevate the eye well, which muscle is incremented? So we have to put the eye in a certain position where only one muscle acts, not two muscles. So we can determine which muscle is malfunctioning. And this is again determined by the angle between the muscle axis and the visual axis or the optic axis. In the primary position, as we mentioned before, the vertical recti make an angle of 23 degrees on the temporal side of the visual axis, and the obliques make an angle of 51 degrees on the nasal side of the visual axis. So in the primary position, two muscles elevate the eye and two muscles depress the eye. But if we move the eye temporally by 23 degrees, i.e. we abduct the eye by 23 degrees, what will happen? The muscle axis of the vertical recti becomes parallel to the optic axis or the visual axis. So the angle between the muscle axis and the visual axis is 0 degrees now. In this position, the superior rectus muscle can only elevate the eye but cannot produce the secondary actions, which are adduction and torsion. And the inferior rectus can only depress the eye In this position, the superior rectus can only elevate the eye, but cannot adduct or produce torsion. And the inferior rectus can only depress the eye, but cannot adduct or produce torsion too. So the superior rectus and the inferior rectus become just elevators. And on the other hand, the axis between the obliques and the visual axis is now 51 plus 23 degrees, so 74, almost perpendicular to the visual axis. In this position, the obliques cannot elevate or depress the eye. We can just do the abduction and the torsion. So if we abduct the eye, and the abduction here is done by the lateral rectus, not by the vertical recti. If we abduct the eye by the lateral rectus, the vertical recti become the only elevators of the and depressors of the globe. So the field of action of the superior rectus muscle is elevation of the abducted eye. The field of action of the inferior rectus muscle is depression of the abducted eye. On the other hand, if we adduct the globe, and adduction here is done by the medial rectus, if we adduct the globe by 51 degrees, the muscle axis of the obliques is now parallel to the visual axis. In this position, the inferior oblique will be the only elevator of the eye, and the superior oblique will be the only depressor of the eye. The vertical recti are now almost perpendicular to the visual axis, so they cannot elevate or depress the eye, but they can only do the other actions of adduction and torsion. So the field of action of the oblique muscles is, for the inferior oblique, elevation of the adducted eye, for superior oblique, depression of the adducted eye. So we have to test motility in the 6 cardinal positions of gaze. On gaze to the right, we are testing the right lateral rectus and the left medial rectus. Gaze to the left, we are testing the right medial and the left lateral rectus. Looking up and to the right, we are testing the right superior rectus, which elevates the abducted eye, and the left inferior oblique, which elevates the adducted eye. On gaze on up and to the left, we are testing the left superior rectus and the right inferior oblique. Gaze down and to the right, we are testing the right inferior rectus, which depresses the abducted eye, and we are testing the left superior oblique, which depresses the adducted eye. On gaze on down and to the left, we are testing the right superior oblique and the left inferior rectus. So we test motility in the 6 cardinal positions of gaze, which is the field of action of each extraocular muscle, where only one muscle is acting, to determine if there is any limitation or overaction of the muscles. We can also test motility in the 9 cardinal positions of gaze. So we add to the 6 cardinal positions the primary position and direct up and direct down gaze. For direct up and direct down gaze, two muscles are acting, so we're not testing actually motility, we're testing for pattern which is difference between the angle of strabismus in up gaze and down gaze. Next, we move to binocular single vision. Binocular means both eyes. Single means one image. So seeing one image by both eyes. As seen in this picture, this object falls on the fovea of the right eye and on the fovea of the left eye. So the brain gets an image from the right eye and another from the left eye. The brain overlaps both images into one single image. So we don't see double vision, we just see one object or single vision using both eyes, or binocular single vision. So the eye is a paired organ. This means we have two eyes. Each eye forms its own image. When the two eyes look at the same object, the two images are fused together into a single image. Fusion occurs in the brain to avoid diplopia or double vision. So this is fusion. Two images are fused by the brain into a single one, or binocular single vision. If the brain cannot fuse the two images into a single one, we see two objects, and this is called diplopia or double vision. And it's binocular. If we close one eye, its image will disappear, and in this case, the patient will see just one image. So any form of diplopia that's related to strabismus is always binocular when both eyes are opened. If we close any eye, the diplopia will disappear. Stereopsis. Stereopsis means to see something three-dimensional and to have depth perception, or see which object is far and which object is more near. So images perceived by both eyes are slightly dissimilar due to slight lateral displacement of the two globes. The two globes are not overlapping, they're laterally displaced. One globe is on the right and the other is on the left. This distance between the two globes makes each eye sees a slightly different part of the object. So this slight dissimilarity makes us have stereopsis, or seeing the object as three-dimensional. So this gives the fused image its three-dimensional feature, or stereopsis. And this contributes to depth perception. We can determine which object is far from us and which object is closer to us. So now we're done with the anatomy and the physiology of extraocular muscles, and the next part of our talk will be on strabismus.